El Nino is building momentum, but we have one more speed bump left to overcome. I'm Mark Sponsler, and welcome to the Stormsurf Video Surf Forecast for the week starting Saturday, September 2nd.
Stormsurf, waves, weather, buoys, altimetry, snow, temperatures, El Nino, weather analysis, essential data for outdoor people, all the time, no hype.
Be sure and like and subscribe. Ring the bell. You get automatic notifications when the videos are posted, typically on Sunday evenings. And if you'd like to make a small contribution, just hit the special thanks button down below, the heart with the $sign in it. And with that, I'd like to thank the folks that donated last week. M. Bories, Scott McMullen, Elliot Harris, Brandon Campshire, Jason Odom, Brett Thompson, C. Parker, and AEF ESQ. Thank you all so very much. We appreciate your contribution, and it helps us make this channel possible. And with that, let's get to work. We'll start by looking at significant wave heights for the South Pacific Ocean, and right now we don't see anything. A little bit of seas in the 20-foot range south of New Zealand, but that's not nearly enough to produce swell that will make it up into the northern hemisphere. Another area of 15 or 16-foot seas, but all aimed south at Antarctic ice and offering no hope for us in the northern hemisphere. So let's take a look at current conditions. We're going to start in Northern California. We're going to use the Point Reyes buoy number 029. We're looking at all the energy that's hitting that buoy all the way up at 33.3 second period, super long period energy. And this is the height for each band period in feet. So we see at like 16.7 feet, 2 feet of swell, plus all this on either side of it. That is a substantial chunk of swell energy. And then we also see down here, the graph goes the whole way down to 5 second period, which is basically unrideable wind chop. We see a little bump at about 9 seconds, 2.4 feet worth of energy. Put that all together, primary swell, 3.2 feet at 17 seconds from 173 degrees. 173. That is a critical number. Supposedly making surf in the 5.4 foot range. Then you have that wind swell, 3.9 feet at 9.8 seconds from 307 degrees, and waves from that, supposedly 3.8 feet on the face. Going down south to Santa Cruz, buoy number 254 off of Steamer Lane there. The same profile without the wind swell. Big bump of energy here in about the 17 second range. Primary swell 2.3 feet at 17.2 seconds from 186 degrees. Now this is sort of wrapping into that buoy. Size is not as big, with surf supposedly at 4 feet on the face. That does not include any bathymetric enhancement, so if you're at a break with a good reef that enhances the size of the swell, it will be bigger. And then down to Southern California, the Point Loma South buoy number 191. We see the exact same profile, a big bump of energy here at about 17 seconds, with energy going out to 25 seconds and down to about 13 seconds, and then, inconsequential wind swell off on the other side. Primary swell 2.8 feet at 16.2 seconds from 181 degrees. That would make surf supposedly at 4.6 feet. Looking at the graph here, this is the calculated surf size from both the primary and the secondary swell. We're just looking to see, has the swell peaked out? You can see here, well, it looks like it started peaking. Hard to say, 6Z last night, that's about 10 o'clock last night, continued the whole way through the day till about noontime in Southern California, then starting to fall off a little bit. So it looks like the peak of the swell has already hit down in Southern California with a 180 degree swell direction and about a 17 second period. That's about 7 hours to get up into Northern California. So the peak of the swell has already hit in Northern California too, and probably will start fading as we get towards midnight. And then finally, south shore of Oahu, Barbers Point, buoy number 238. Profile shows little background southern hemi energy in the maybe 15 to 14 second period range. Some wind swell in the mix there. Primary swell 1.5 feet at 14.8 seconds from 195 degrees. That would put surf in the 2.3 feet, so we'll call it waist high. All right, so what's going on? What has generated the swell that is primarily hitting California? So we're back to Thursday, August 24th. Little gale started developing in the far southeast Pacific here. We can see it as it started to grow with 28, 30. Oh, now see, this is the highest seas in this whole domain, but the big gale was south of Tasmania here, and none of that energy really is working its way into the northern hemisphere, into our forecast area. So this is the primary swell generator here. We'll say 31-foot seas. Southern California, San Diego is about 117 west, so right about here. So it's in the swell window, but about as south as it can possibly get. Northern California, Santa Cruz is at 122 west, so right here. So this swell angle, I went and calculated it all out. It's about 178 degrees coming into Santa Cruz, and then about 180 relative to Southern California. Now, another gale developed right behind that on Sunday, the 27th of August. This one a little bit stronger with 33.5-foot seas. Again, right there, this is the location. Winds 51 knots, and actually built a little bit more to 36 feet late Sunday night, and 37 feet. But now the key thing here is San Diego at 117 west. Most of these seas were east of even the Southern California swell window, though there's still a good 30, 32, 34, probably 35-foot seas in the Southern California swell window. And then that moved off. Now notice another little gale here developed southeast of New Zealand with 20, 22, 24, 26-foot seas. This was on Tuesday, the 29th, lifting northeast. That swell is pushing northeast towards Hawaii. So it's like, hey, we actually have summer here. And even 22-foot seas lasted into Thursday night. That would be the 31st of August. Of course, pretty good, well shadowed here by Tahiti and surrounding islands. So that gets us to today, and things are pretty calm down south. Let's go look at the future. But before we do that, we did get the Jason 3 satellite to pass over. This is the first of that gale in the far southeast Pacific that supposedly, this was on, what day was this? The 18Z on Thursday, August 24th, as the gale was just getting organized. And you see this dark red here, that's 28-foot seas. This is the actual track of the satellite. It's radar beam bouncing off the ocean surface. Now look at the colors here, and you go, that's at least 30-foot seas per the guide over here. So, and here's actual, this is a 15 reading average over the peak seas here. It said seas were 33.3 feet, so, and the location 57 and 132, so that'd be like somewhere right around in here with a single reading. Now this is only, I don't know, maybe 100 or 200 yards long, something like that for each individual reading, but of 37.7 feet at basically the same point, so down in here. So seas were definitely higher than what the wave model suggested. We got another pass too, the same sort of deal. Seas were 31 feet per the model. The average measurement was 36.9 feet, so another 6 feet higher or more than what the model said, with a single reading at 40 feet. And where was that at? 55 and 120.54. Oh, so that's, yeah, right over in here. So seas, again, considerably higher than what the model said. And then on the second gale down there, the same deal. It supposedly had seas of 32, 4, 6, 37 feet, 37 and a half feet, somewhere like here. But you can look right here, all this is gray on the scale. That's 40 feet or above. The average measurement was 43.1 feet with a peak reading at 49.4 feet. Now, I don't really believe the peak reading. That could be two wind waves intersecting at the same time and the satellite just happened to catch it. But still, 43 feet, considerably bigger, 6 feet bigger than what the model said of, 37 feet. So both these systems overperformed compared to what the model said they would do. That is good news. And the net result is larger, more energetic swell than one would expect, and you could see that with 20-second and 18-second periods arriving yesterday on Friday and into Saturday morning, and you can't get that really from 32-foot seas or so. So, swell did better than expected. All right, so what's coming? We're looking at jet stream level winds. This is the forecast for the next week. And jet stream level winds are about 30,000 feet. We're interested in them because they help create or support the formation of gales when those gales form and help direct their track. We're looking for a trough, a push in the jet, this branch, the southern branch to the north. Now you can see right now we have the northern branch, which really doesn't have that much influence on gale development. It's been exceedingly strong for all summer. The southern branch, pretty weak right now. The ice line is down about 64 south, something like that. And then crashing further south into basically Antarctica, offering nothing for the moment. We're looking for a trough, a push to the north, and there we go. It's supposed to start on Monday, the 4th of September. What that helps do is create a clockwise flow aloft, like a clockwise eddy. It also happens down at the ocean surface. That's the hallmark of low pressure in the southern hemisphere, and of course low pressure generates winds. Winds, if they're strong enough and aimed in your direction, generate seas. Seas, as they move away from the fetch area towards your beach, turn into swell. They get groomed out, and that swell, of course, when it hits your beach, turns into surf. So we have another opportunity Monday into Tuesday into almost looks like Wednesday and Thursday before that trough weakens and pushes east of, there's 120 west, east of the Southern California swell window. And then theoretically another opportunity 180 hours out on Saturday night, the 9th of September in the far southeast Pacific. So here we are in September, and summer has finally decided to restart itself. It is not unusual to have a lull in July and the early part of August and then have things wake up down south. So we're kind of right on track. We'll take it. So that was the jet stream view. Let's go take a look down at the ocean surface. Surface level pressure and surface level winds. We see a weak low pressure system. Now there's one low here, but that's all over Antarctic ice. The ice line, again, about 64 to the south. Little low south of New Zealand, 35 knot winds. That's not doing anything. Another low over here with 35 knot winds aimed south. So no real support for gale development, but we know there's a trough, and somewhere on Monday tries to get organized. 35 knot winds. We even have 45 knot winds there, but this low falling south, this is what they call a complex gale, where you have multiple low centers all sort of spinning around each other. The system never really gets super organized, but by Tuesday, the 5th of September, 30 to 35 knot winds aimed north, getting more consolidated, a broader fetch of 35 to almost 40 knot winds, and then 45 knot winds on Wednesday aimed north, and then pushing out of the Southern California swell window, but maybe a chance for yet more swell from that. And then another one starts developing almost a week out. Don't believe the model's that far out, no more than maybe 3 or 4 days. But on Saturday, the 9th of September, perhaps another opportunity in the exact same location. It seems we're on a roll. So what is the effect of those winds on the ocean surface? Well, we know there's a trough and a low trying to organize here on Monday and Tuesday, but you need pretty much 26-foot seas. We're not seeing it. There we go. Finally, 20, 22, 24, we'll say 25-foot seas on Wednesday, the 6th of September. There's your 26-foot seas. That's a 15, 16-second period aimed off to the north with a chord of 32, 34-foot on Wednesday night, lifting well to the north. Now, the models have been kind of all over the place. They don't have a very good handle on this thing yet, but theoretically, they've been consistently now for multiple days showing some sort of low developing in this area with seas above the 26-foot threshold. So it looks like we have an opportunity there. And then we know we have another one trying to organize here about on Sunday, September 10th, and that's a week out. We'll just have to see how that plays out. And then a quick look up north. Now, during El Nino years, typically the jet stream in the North Pacific kind of fires up early. You get that can grab tropical systems over here, cause them to recurve off, so they normally travel east to west. They get caught somewhere off Japan. They do the round turn. The jet stream can catch them, push them this way, and they can go extratropical and do some amazing things. But the jet, for right now, we're on Sunday, not looking particular, just sort of fragmented. It's trying to organize, but not really doing it. Theoretically, we have a big ridge here, but a dip in the Gulf of Alaska, theoretically on Thursday, but it just doesn't have that look, not like a really clean trough to support gale development. And then maybe another trough organizing a week after that. So we're watching, nothing clear indicated in the jet stream yet for the North Pacific, so South Pacific remains the focus. But just to make sure, we'll take a look here at the significant wave heights for the North Pacific Ocean, and we're looking for 24-foot seas, something like that. Now, you do notice some sort of a tropical system forecast here pushing under Baja, 156 hours out. Don't believe it yet, but you never know. And you see a gale trying to fall into the Gulf of Alaska. Now, that's a bad frame there, but a gale trying to fall into the Gulf of Alaska about a week out. Too early to know, but for right now, no clear signs of real North Pacific energy. We will watch for this tropical system, but right now, we're not even going to go dive into those details because it's not there yet. Local wind conditions for Northern California, or all of California right there, Hawaii there. High pressure in control, but not near the coast. Light winds today on Saturday, all day in exposed breaks. It was a miracle. Hard to believe. Even a little bit of, I wouldn't call it rain, but mist falling, like there's some sort of a cold front trying to push through. And we got a report up in the Sierra of snow, sleet, grapule falling, and rain at lower elevations. So something's trying to happen. Wouldn't say, maybe it's the first tease of fall. Anyway, light winds for California, and on Saturday, trades 15 knots for the Hawaiian Islands. As we get into Sunday, looks like more of the same, maybe a little bit of a bit more northwesterly wind for North and Central California, 10 knots. Light trades for the Hawaiian Islands. So we get into Monday, high pressure starts trying to build in. Northwest winds 10 to maybe 15 knots for North and Central California. Trades very light for the Hawaiian Islands. Tuesday, high pressure in the typical summertime pressure gradient starts trying to build some more, 15 knots, maybe 20 knots off of Cape Mendocino. Some small wind swell trying to get a foothold. Light trades for the Hawaiian Islands. Wednesday, more of the same. Thursday, more of the same. We're out to Friday, more of the same. Here comes the tropical system pulling in from the south. You see it there. Again, don't believe it yet. And then as we get into Saturday, high pressure in control, 15, 20 knot winds along the North and Central California coast, light trades for the Hawaiian Islands, and theoretically, looks like a bomb of a tropical system, and with maybe some swell generation potential, we'll say for Southern California. But again, it's way too far out. Something to keep your eyes on. Look at the models. Keep yourself informed. Select location surf forecast. See surf heights right here, 2 to 3 feet, 2 feet basically. These are wind speeds here, local wind speeds. And the good news here, sort of looking at this, it doesn't look so bad except for a couple little spots there on Sunday and Monday. But other than that, not bad at all. And that's Sunday, that would be in the afternoon. All right, swell heights. So it all looks like wind swell, though we know there's southern hemi swell buried in here. The model gets, if the wind swell dominates, then the southern hemi swell can't really show up. So let's go take a look down south. Dana Point, better proxy, and it's good enough for Northern California, too, for these real southern angled swells. Surf heights in the 3 to 3.5 foot range, then slowly tapering down. And here's the real picture. Swell 2 feet at 16 seconds on Saturday. Actually, it exceeded that considerably. So the model, again, remember, the Jason 3 satellites suggested seas were way higher. So the model pretty much got that wrong. Swell slowly dropping in period, size pretty much holding on into about Monday. Next pulse shows up, 18-second period with swell heights in the 2 foot range. Again, that's probably understated a bit, and continuing the whole way through the 10-day forecast. So continuous southern hemi swell for California. Oahu, South Shore, not a whole lot going on until you get into late Monday and Tuesday. Surf heights come up to 3.5 feet roughly, and that's Hawaiian. That is, you could read it as Hawaiian. It's calculated surf height, but it doesn't presume that there is a reef or anything. The reef magnifies that by some amount. But here we go. You can see the arrival of the new swell on Monday evening, pretty much after sunset. 16.8 second period with heights going up to 2.7 feet at 13 to 14 seconds as we get into Tuesday and Wednesday, and some sort of surf the whole way through at least Thursday and maybe beyond that. So everybody gets a taste of the action. Finally, summer has started. And that brings us to the second half of the presentation, the long-term outlook. We're looking at the Madden-Julian Oscillation, the MJO, and the El Nino Southern Oscillation, ENSO. These two weather cycles are the main contributors or clues we can use to project what the weather and the surf might be like going out weeks, if not months, if not a year or more. So we'll start with the MJO, the Madden-Julian Oscillation. It is a periodic weather oscillation. It has two phases, the active phase and the inactive phase. The active phase is the one we're interested in. It is like a low-pressure system. The inactive phase like a high-pressure system. These two phases rotate opposite sides of the planet from one another. The active phase on one side, the inactive phase on the other. They rotate west to east around the planet on the equator. It is the active phase that we're interested in because it, one, imparts energy, warm, because it's a low pressure system. When it moves over the far west Pacific, it sucks up warm, moist air from down at the ocean surface, spews it high up into the atmosphere. That in turn, that energy gets caught by the jet stream. It energizes the jet stream, and a more energetic jet, be it in the northern hemisphere or the southern hemisphere, then helps create troughs, which help create low pressure systems, which help create surf. All right. The inactive phase basically does the exact opposite of that. It's a high pressure system. It cuts off energy to the jet splits and weakens, and then you end up with a bunch of high pressure. Now, going back to the active phase, the other thing the active phase does is when it's in the West Pacific, it helps dampen trade winds and reduce trade winds in the West Pacific, then allow warm water that's normally sequestered in the far west equatorial Pacific, allows it to start flowing east underneath the equator in a thing known as a Kelvin wave. It's like a ball of warm water, traverses west to east under the equator, takes 4 months to make it from the West Pacific to the East Pacific, but eventually it hits the Galapagos Islands in Ecuador, it erupts to the surface, creates a slick of warm water. Now, if you have multiple active phases of the MJO in quick succession, and they're strong enough, they create multiple Kelvin waves. And multiple Kelvin waves, once they all start erupting, you get a pool of warm water that starts developing off of Ecuador, and it starts evaporating, allowing moisture up way into the atmosphere, and that starts changing the jet stream pattern, and that is what creates El Nino. All right? If you've been watching this video, as I'm sure you have, you know we've had 5 Kelvin waves traverse the Pacific starting in December in through about May, and then everything kind of shut down and things went to sleep. Now, the good news is somewhere in late July, early August, the MJO kind of woke up. We got more westerly winds in the far west Pacific, and another Kelvin wave has been generated. That is good news. And so we're going to go look at what's going on right now in the Pacific. This is data from the TAO buoy array, series of buoys strung across the equator used for monitoring El Nino, but they also have wind sensors on them. Again, the active phase of the MJO, a low pressure system, can dampen trade winds as it traverses the Pacific. It takes, about 4 to 6 weeks to move from the West Pacific to the East Pacific, and as it's moving, see these little arrows pointing out of the west while all the rest of these arrows point out of the east? That's the dampening of the trade wind pattern we were talking about. So it looks just at the given the actual wind speeds, well, you see here, in the East Pacific, wind's pretty strong out of the east. The longer they are, the stronger the wind. Central Pacific, same deal. Oh, this is the equator here, sorry. Dateline right there. That's New Guinea there. But when we get into the West Pacific, we actually have west winds, not west anomalies. That's not lighter than normal winds. This is out and out west winds. Down here is the anomalies, difference from normal for this time of year. Yeah, we have strong east winds, and they are a little bit stronger here in the East Pacific than normal, pretty much neutral in the Central Pacific, and fully out of the west in the West Pacific. So it looks like the active phase is setting up. Now, one other bit of data. If you are in El Nino literally acts like a continuous long-running active phase of the MJO. So this might be the MJO, or it might be the first real signs of El Nino coupling with the atmosphere. What's that mean? Well, we talked about the whole Kelvin wave thing, right, in warm water, and that is what starts to change the atmosphere. But the atmosphere has to really dig in, and it takes months for that warm water pool off of Ecuador to start seriously influencing the jet stream and the weather patterns globally, all right? It starts in the Pacific, and then it has to work its way the whole way around the planet, okay? We're thinking that maybe that is happening, that the ocean and the atmosphere are starting to become coupled. So we're going to look for signs of that as we dive through all the details here. All right, let's keep going. Just a quick look here. This is the east-west component of the winds, 850 millibar vector wind anomalies. And there's South America, Central America, Hawaii, New Guinea there. The reds and oranges are westerly anomalies, synonymous with the active phase of the MJO. It only has to be, really though, the area is 5 degrees north and south of the equator. The equator is right there. So we see westerly anomalies pretty much over the whole West Pacific. 27th of August, same deal on the 28th, 29th, 30th. If anything, building on the 31st. This is good. It looks like at least the active phase of the MJO. So what is the forecast for the next 2 weeks? This is the GFS model here. This is what has happened in the past. This is the future. Oranges and reds, westerly anomalies, but they need to be in a very specific area in the West Pacific to create a Kelvin wave, and that's what we really want to see. In that area from 120 east, which is pretty much where New Guinea is, just to a point just east of the date line, 170 west. So right in here, you see we've had pretty much consistent, some form of westerly anomalies the whole way through August. But here we are today, September 2nd, GFS model, and it's been saying this for 2 weeks now because we didn't do a video last week. Easterly anomalies building, inactive phase of the MJO. Now the good news is here, that's 5 days, that's 10 days. 10 days from now, according to this, westerly anomalies start creeping back. And this looks like the inactive phase of the MJO. So this up here looks like the active phase pushing through what we call the Kelvin wave generation area, the West Pacific. That's where you want the west anomalies in the West Pacific to create the Kelvin waves and to really help feed the cycle. And then things kind of stalled. Now we're in the inactive phase for 10 days. We were thinking it was going to be far worse than that last time we made the video. Now, 10 days, completely doable, not unexpected. And after that, westerly anomalies theoretically start building. Let's keep digging. If the active phase of the MJO is a low pressure system, then it will likely, as it's pushing warm moist air up into the atmosphere, will create clouds, right? So this is a model of outgoing long wave radiation used to project to predict the MJO. Outgoing long wave radiation, what's that mean? Well, if you have a satellite and you're beaming, let's try another way. If you're the sun and you're beaming energy down on the ocean's surface, if there's clouds, that sun will not escape the surface. So there won't be a lot of radiance coming off the ocean, okay? The blues here on the scale, and you don't see anything, that would be more clouds than normal. The yellows, less clouds than normal. So this would be the active phase of the MJO. This would be the inactive phase. And here we go. South America, Central America, Hawaii, New Guinea, equator right there, date line right there, 4 panels, each 5 days. So this is a statistic model that says no MJO right now, no MJO, a neutral pattern 5 days from now, and then 10 days from now, a weak inactive phase and holding 15 days from now. Now, the dynamic model paints an entirely different picture. It says neutral, neutral, active phase developing about a week from now and holding 2 weeks from now, and if anything, getting pretty strong. So Two different models, two totally different outlooks, but the dynamic model is, I think, notice, remember we looked at the previous model, GFS said easterly anomalies for 10 days, and then westerly anomalies perk up, and starting about 10 days, here comes your active phase of the MJO with your westerly anomalies. So that makes sense. Let's dig a little deeper. A deep dive into those two models, statistic model, dynamic model here. What are these charts? They're called phase diagrams. They just show you where the active phase is and how strong it is. They don't talk about the inactive phase, just the active phase. The active phase moves from west to east, from the Indian Ocean to the Maritime Continent, over the West Pacific, over the East Pacific, under the United States, across the Atlantic, over Africa, back to the Indian Ocean. The heavy dot right there is where the active phase is right now, so I guess that's the West Pacific. Yeah, you see it noodling around, and yes, I'd say that's the West Pacific. But if the dot is out here, the further outside of the circle, the stronger the active phase is. If it's right here, it's exceedingly weak, and here are the forecast tracks for it moving into maybe over Africa and ridiculously weak. Now, the dynamic model paints an entirely different and much more encouraging picture, suggesting the active phase getting modestly strong, still in the East Indian Ocean, almost the Maritime Continent, then moving solidly over the Maritime Continent 2 weeks from now, but again, very weak. So no strong MJO signal is forecast. Now, let's be clear. During El Nino, the MJO, both the active and the inactive phase, sort of disappear. The more the El Nino is coupled with the atmosphere, the weaker the MJO becomes, and the signal from ENSO takes over, a persistent westerly anomaly pattern. Remember when we were looking at the models, they showed consistent westerly anomalies, and there wasn't any clear signs of an active MJO in place. So what's going on? Well, just maybe, that's a sign of coupling of the ocean and the atmosphere in El Nino, something we've been waiting all summer to see happen. Upper level model showing areas favorable for precipitation. The greens, wet air, the oranges and reds, dry air. Green would be the active phase of the MJO, orange is inactive phase. So, and this is 8 panels going out 5 days each, South America, Central America, New Guinea, equator there, dateline roughly there. Looks like active phase of the MJO, a weak one, currently over the West Pacific, and then fading out by September 17th, and then the inactive phase setting up, making its trek across the Pacific into about the 12th of October, but by the 7th of October, the active phase showing up again. This is a statistic model. Take this with a grain of salt, especially when you see what's coming up in some of the other models. Next up, the CFS model, going out 1 month. All right, past performance here, the forecast down here, dateline running right up the middle. All we care about is the Kelvin wave generation area, the West Pacific starting about 125 east, so just draw a line right up there, and ending at about 170 west, so right there. This is the east-west component again of the wind. Again, reds are westerly anomalies, the active phase of the MJO. In fact, the solid contour here is the active phase of the MJO. Okay, the dotted contour, the inactive phase. So we're back in late June, early July. You see westerly anomalies. Inactive phase of the MJO didn't do a whole lot. It's pretty much westerly anomalies. Started somewhere, what did we say, about the 10th or 12th of July. And pretty much nonstop westerly anomalies up to today. Now notice here, this chart actually shows a legit inactive phase of the MJO traversing the Pacific, but only, well, that's a week, only for about the same deal, the next 10 days. And even before that, westerly anomalies a week from now start building on the dateline, backfilling, and strong, notice little signs of the active phase of the MJO starting mid-September. Totally different from what that statistic model showed that we were looking at before. I would trust the dynamic model a lot more. So this looks like exactly what we want to see. We can take a week to 10-day bump without westerly anomalies. That's no big deal, especially if you get this. Now, the CFS model has kind of been overhyping this for months, but the hard reality is it's just been a pretty much steady, weak but steady westerly anomaly pattern since, the second week in July. So all the doom and gloom and the hand-wringing that I've been sort of dealing with for past month or two about this weaker pattern really now is beginning to feel like, well, maybe El Nino is getting a little bit better control of the atmosphere, and the models have been overhyping the forecast for massive east anomalies, and they just never materialize and never materialize. And now, personally, I'm starting to become more disposed to saying, I think we're moving in the right direction. And that was the theme of this week's video. Let's dig deeper. All right, so we're going to look at outgoing long-wave radiation forecast and what's really been happening. Okay, this is, and let's scroll up. Here we go. Kelvin wave generation area starts right here. The forecast is up here. What's been happening is down here. Kelvin wave generation area starts there, goes over to about there, the date line there, so 170 west there. The blues are more negative anomalies, more cloud cover, less outgoing long wave radiation. You notice here, it's kind of spotty, but a consistent pattern of more cloud cover over the dateline region and a building pattern of high pressure over the maritime continent into the Indian Ocean. That's exactly what you would expect to see in a building El Nino. And the forecast looking forward, well, you can see here, steady building cloud cover focused right on the dateline with steady yet more building dry air, cloud-free air over the maritime continent and the Indian Ocean. And then we go take a look at our dear, beloved westerly anomalies, the fuel for El Nino. Again, the forecast, what has happened down here, and here's that beginning July 12th pattern, westerly anomalies, westerly anomalies, a little bit of a backup. Here is the forecast for that 1 week right in here of easterly anomalies, and then according to the CFS model, we're off to the races after that. And what's even more impressive is, yes, we have westerly anomalies on the dateline feeding El Nino, feeding into a developing Walker circulation, but we also have falling dry air. This is rising air here. We have falling dry air over the maritime continent. Again, a clear signal of El Nino. So then we overlay the MJO, the signal, all right? Solid contours, the active phase of the MJO. We're out of the active phase of the MJO. It finished up maybe 2 weeks ago. The dotted contour, the inactive phase of the MJO. Forecast to continue into maybe about mid-September, something like that. But notice, westerly anomalies start building by the 10th of September, even while we're in the inactive phase of the MJO. Active phase sets up after that. Westerly anomalies, more active phase. Just assume that these two are all one active phase, continuing solidly into November, and that's about probably when the peak of El Nino atmospherically, just from a Kelvin wave Walker circulation thing starts getting going, with the inactive phase building after that with westerly anomalies, those still well in control because El Nino takes over, the MJO pretty much disappears. It's just sort of a little road bump in the bigger pumping machine of the development of El Nino. Let's overlay the low-pass filter. It really clearly paints that picture. The solid contour, a low-pressure bias, the El Nino signal. The dotted contour, the high-pressure bias, the La Nina signal. So California's right-centered about 120. You see the last remnants of the high-pressure blocking wall, the remnants of La Nina, the thing that's been generating or feeding that cool pool that was hanging off of California all spring and all summer. Well, by October 4th or 5th, it's supposed to be gone. We've been watching this. It's been consistently somewhere between October 11th and 18th. Now the model says October 4th. That's only a month away. We'll take it. And even more so, the low pressure bias, the building El Nino signal with 1, 2, 3 contours that have been in place since, again, that key July 12th date, solidly in control, getting stronger with a 4th contour forecast developing November 5th and beyond. This looks pretty solid and pretty impressive. Now, it is a model. We don't always believe the model, so let's go do a quick check on reality, at least on the little bit that we know. For one, we've been looking at westerly anomalies. We've seen it on multiple data sets already, that they started on July 11th and they pretty much haven't stopped. So all this looks good for now. But what about that outgoing long-wave radiation? All right, outgoing long-wave radiation anomalies. The oranges and the date line, again, this is the whole plan on one chart. This is actuals to date, starting a year ago, September 2022. The oranges and reds, clear skies, the La Nina signal right over the date line, with the blue, the wet pattern over the maritime continent. And then we get into right here, the beginning of May. And look at that, as we get a little bit of blues start moving from the maritime continent into the West Pacific. And then by July 12th, which was right about here, right when the westerly anomaly started taking hold, a building wet pattern, cloud cover pattern building over the dateline, continuing to today. Clearly a break from that to this, a switch, a complete switch. And notice, the blues that were here, we're looking to see more yellows start building over here over the maritime continent. Not quite as clear a building pattern yet, but the suspicion is as we get into September and October, the blues will build, the oranges will build over here, and a more defined El Nino signal will become apparent. And then that tells us that the ocean and the atmosphere are fully coupled. Right now, we're looking at a nanescent, the beginning parts of that coupling, where a couple of weeks ago, we were going, we're not even sure there is coupling. Now, I'd say there probably is. Not super strong, but it's definitely there. All right, so what's going on in the ocean? Let's take a look down in the ocean, do the Kelvin wave analysis thing. This is data from the TAO buoy array, the series of buoys strung across the equator used for monitoring El Nino. These are the anchor lines on those buoys. The X's are sensors that are wired into the anchor line. The sensors collect data, use a model to fill in the copious gaps in between those sensors to get a profile of what's warm water doing. During La Nina, you have cold water over here, warm water all sequestered in the West Pacific. During El Nino, the warm water that was all over here starts pushing east. Just looking at this without any details, clearly that's what's happening. The 30-degree isotherm, 30 degrees centigrade, well, it's at 170 west. That's where it's been. It hadn't changed. 29-degree isotherm, I think it was at 158, maybe the last video. It's moved over 1 degree, no big deal. The 28-degree isotherm, still locked at about 140. But the good news here is the 24-degree isotherm, it was up to only 50 meters deep. Now it's down to about 37 or 38. We think it's going to build some more. Why would that be? Well, maybe there's another Kelvin wave in flight. So we go look here at the anomalies. The difference from normal for this time of year, we see a bit, how do I say this? There was a smaller pocket of warm anomalies here 2 weeks ago. It has built back to the west considerably, and there's this clear lobe of 2 degree centigrade warm anomalies here, suggesting this is Kelvin wave number 6. Last video we were talking about it. It is building, moving to the east, adding more warm water to the already pre-existing El Nino warm pool that was created over here by 5 other Kelvin waves that traverse the Pacific the first half of this year. They're getting reinforced now. All this looks good, and there was a little lobe of cool anomalies somewhere in here. That's all gone now. This looks like El Nino. A different version of that, using different technology, also paints the same picture, an expanding area of warm water the whole way back to 170 east now. This is the new Kelvin wave here, working its way off to the east. It's got 3 months plus to make it over to Ecuador. So where are we? September, October, November, and that's typically what you'd expect to see. A lot of upwelling in this area, and then still the trades have to take this warm water, start pushing it back east on the surface. Remember, this is down in the ocean. Okay, so there is a large, solid reservoir of warmer than normal temperatures in the Pacific, all moving off to the east. Just another really good sign. Pentad sea level anomalies. This is data from the Jason 3 satellite and probably a couple others. They rotate around. What they're trying to map is the height of the sphere of the ocean. Okay, think about that for a second. You take the waves out, the wind waves out, even the tides, and is the sphere of the ocean higher or lower than normal? Why does that matter? Well, cold water, if you have cold water at depth, cold water contracts, it's denser. You get a little divot on the ocean surface. Likewise, if you have warm water at depth, it expands. It'll create it displaces the water above it, creates a bump on the ocean surface. So using this technology, you can get a sense of what the water temperatures are down 150 meters in the ocean. That's down like 500 feet. All right, so what are we looking at here? Chile, Peru, Central America, Hawaii right there, equator there, dateline there, New Guinea there. All right, so we did see a bunch of higher than normal anomalies here, suggesting warm water here. But you know what? It's very normal for this time of year for that to all collapse. Okay, but we see from about, I'll say even, what's that? 165 east, positive anomalies, and building 5 centimeters or above here at 160 west, the whole way into Ecuador with a big pool of 10 centimeter anomalies here. So a good supply of warm water to feed the building El Nino warm water surf. This is subsurface. These aren't temperatures now, remember. This is an inference of what's going on subsurface. All this has to bleed up, erupt to the surface here, and then get tracked back west by the trades, feeding the atmospheric change that we believe is happening right now. So again, this looks positive too. And probably my favorite chart, the upper ocean heat anomalies, but this is over time, a year. West Pacific here, East Pacific here. Last year, this time, cold water in the East Pacific, the La Nina signal, lots of warm water sequestered deep in the ocean in the West Pacific, and then in late November, December, see warm water leaching across the Pacific. That's Kelvin wave number 1. Created by the active phase of the MJO. It wiped out most of the cold water. Kelvin wave number 2 comes across, starts building warm water off of Ecuador. Kelvin wave number 3, number 4, and mighty Kelvin wave number 5 in May, pushing the whole way across, making a massive pool of warm water. Now, a lot of that started discharging, but then here we go in July, Kelvin wave number 6, and our building warm pool from 162 west the whole way into Ecuador. Now, you see here the beginnings of neutral temperatures here. We think even if we did have a solid active phase of the MJO, there's no warm water left here for the for west anomalies to really tap into to feed any more warm water into this, but we have an adequate supply now. There's at least 3, if not 4 months worth of warm water sitting here. And then there's still months of, this is all subsurface. Once it gurgles up to the surface off of Ecuador, it still has to flow back to the west, and that will continue to feed the Walker circulation and our El Nino pattern. Really looks like we are in business. Next up, sea surface temperature anomalies. All right, this is even more important. This is what's going on at the surface. Chile, Peru, Central America, Hawaii out here, the equator right here. Cooking warm temperatures. What is that? 4, 5, 6 degrees above normal in this area. There's the Galapagos Islands right there. So we had a bit of easterly anomalies here that were obscuring this, but now looks like we're back in business. A solid El Nino signal. This is exactly what you want to see during El Nino. Warm water. And look at it. It's starting to move off to the west. Now out to, we'll say, 145 west. The best we ever got earlier this summer is 135 west. So this should show a steady increasing building warm signal on the ocean's surface, creating evaporation, feeding the Walker circulation, changing the jet stream, all the things that we've talked about earlier. This certainly is suggesting that's in play. Now, also notice, cooler than normal waters. This cold water here was all along California all spring into all summer. About 3 weeks ago, it started to break with the north winds along California finally dying. The last little bit of the enhanced trades from La Nina still hanging in this area. Pretty much irrelevant at this point. We'll keep our eye on it, but we expect this to completely start dissipating at some point too. And notice, warming temperatures building all off the California coast. Plenty of fuel for this coming winter. The trend for the past 7 days, all right, yeah, we do see there's Ecuador right there. A couple little pockets of cooling, but nothing significant. But overall, basically, there's warming off of Northern California, but overall, a pretty steady state pattern. No big dips in temperatures. We wouldn't expect any big rises. It can't get any warmer off of here. And this is just a 7-day trend. So basically telling us we're in business. And then finally, the backed off view here. All right. This, again, the classic El Nino triangle right there. You can see it plain as day. Not a whole lot more needs to be said. Sea surface temperature trend in the Nino 1.2 area. This is the area right there along Ecuador and the Galapagos. Temperatures today plus 2.876, down a little bit, but pretty much they've been record highs since, well, since back in June. So that's good. It's just a big supply of warm water so that the trades can tap that warm water, start pushing it off to the west, move it into the Nino 3.4 region. This is the region on the equator from a point south of California out to about the dateline. Steadily improving temperatures today, plus 1.175 degrees. So El Nino starts at half a degree above normal. Weak El Nino is half a degree to 1 degree, so we're above that. Medium El Nino starts at 1 degree up to 1.5 degrees. Now, this said, we think this data is low. So we're going to try to do this. This is weekly sea surface temperature data for the Nino 1.2, Nino 3.4, and Nino 4 areas. Let's see if I can scroll through this real quick. And here we go, Nino 3.4 here. And starting in June, temperatures 1 degree, 0.9, 1, 1.1, 1.2, 1.2, 1.3, 1.5 degrees above normal. So the previous data we looked at said 1.1. This says 1.5 as of August 23rd. That puts you into strong El Nino category, 1.5 to 2.0 degrees, and 2.0 and above is super El Nino status. So again, 1 week is not a trend, but you can see this steadily building trend with a steadily building coupled ocean atmosphere ENSO experience occurring. And let's look at one other thing. Sea surface temperature anomalies for the Nino 4 region. That's out beyond the dateline. Temperatures heading up. Nino 1.2, pretty much steady. Nino 3, but it's Nino 3.4 we're interested. 1.5 degree we got from that weekly data. This says, well, there's the 1.5 line right there, and it says we are there. We got a hold there, but it certainly looks like there's piles of water in these other areas east of there to continue to feed this. Kind of looks like we're in business. I don't want to say we're in the strong El Nino category yet because we're not, but oceanically speaking, we're really close. All right, so there's sea surface temperature anomalies for our current event in 2023. Looking pretty solid. This is the classic El Nino triangle right there. Here's the El Nino from 2009 at the exact same time, September 1st. Can't even compare it to what's happening right now. Literally no comparison. So let's do another comparison. There is the 97 El Nino. Now that looks much stronger than the 2023 El Nino. But maybe, actually, let's see. 2023, yeah, not as solid in here. Warm water doesn't go out as far as 1997, but still, actually, not horribly different. Weaker, but not super weak. And then finally, one more. The 2015 El Nino, our existing El Nino, blows the 2015 El Nino away. There is literally no comparison, at least at this point in time. So, as just looking at these charts, and let's see if I can find that last one here. You can flip through all these. There's 2023, 2015, 97. We'll just go back and forth. 23, 15, 97, 23, 97. Yeah, we can't compete with the 97 one, but we're certainly way above the 2015. All said and done, at least right now, it looks pretty impressive. And I have a hard time saying that, but this El Nino it's very east base, it's solid, and it just doesn't seem to want to let go no matter what the atmosphere is throwing at it. So, maybe not a bad situation. Okay, current-wise, what's going on? So this is South America, Ecuador, the Galapagos Islands. We see a strong east current here, but if you look over here in the far west Pacific, you see a strong west current. The convergence point between those two currents is right about, I'd say, here. And that you can't see it, but that's 166 west. One would assume if the Walker circulation is pushing up into the atmosphere, you'd have two currents on the equator coming in either direction to it and going up. That split point looks like right here. The outgoing long wave radiation, which we saw on previous charts, is actually somewhere over, let's see, right about there. So all this sort of correlates to suggest it looks like we have an El Nino pattern in play already, both oceanically and a building one atmospherically. This is exactly where you want to be as you're moving out of summer into the start of fall. Let's go look at the forecasts. Actually, before we do that, one last look. What does the atmosphere think is going on? The Southern Oscillation Index, difference in pressure between Darwin, Australia, roughly over the maritime continent, and Tahiti in the central Pacific. Okay? When pressure is lower in Tahiti, right here, versus Darwin, relatively speaking, the index goes negative. That means either the active phase of the MJO or a building El Nino. When pressure is stronger over Tahiti, then you're in sort of an inactive phase or La Nina. Today's contribution, minus 21.21. The good news is, look at this, we've got 15 days of negative readings here. We had maybe 7 days of neutral readings, and then before that we had another 20 plus days of negative readings. This is a very good sign, suggesting that we have lower pressure consistently setting up over the equatorial Pacific as compared to Darwin, a classic, another sign of a developing El Nino. The 30-day average, now it's only minus 12.12. Where were we a month ago? Well, we were at minus 6.39. You see it dipped to 13, it started to rise to 8, and now we're falling again. And we're probably going to rise again a little bit with that 1 week to 10-day easterly anomaly inactive phase of the MJO. But it looks like we're on the right track. The 90-day average, minus 5.61. This needs to be down at 15. This needs to be down at 20 or 25. But we expect that's where we're going to be about 3 months from now. What's the trend been? Well, we were at minus 8 or something. We're at minus 5. This speaks to the weakness of the MJO and the weirdness that was going on back in July and early August. But the full expectation is both these indices will be starting to move negative. Here's the 30-day moving SOI graphed out. Back in 2021, 22, when we were in La Nina, oh, here's the zero line here. You're above the line, you're in La Nina, or at least the inactive phase of the MJO. The pattern was solidly favoring the inactive phase of the MJO, and that was La Nina. And then beginning this year in January, boom, we just fell into a massive long-running active phase of the MJO. Here's that weakness we talked about in July. But look at this, we're heading down. We think we might head up for a week. But I think after that, we're off to the races, and this will be continuing down. But that's just my guess. Looking at the hard data, though, we are at least somewhere in the active, a long-running active phase bordering on El Nino. The atmosphere certainly knows we're not in La Nina, and we're not even neutral. We're moving our way in the right direction. And finally, the forecast for sea surface temperature anomalies in the Nino 3.4 region, the official El Nino monitoring region on the equator from the CFS version 2 model, which is pretty good representative of all the dynamic models. All right, so where are we? We're July, August. We're starting September, so somewhere right there. This says temperatures at 1.35 degrees. Strong El Nino starts at 1.5. We should be there about mid-September. By October, solidly in the strong El Nino category, moving to the upper end of it by November or so, and then a slow fade from there. Now, this is the more outlandish of the uncorrected CFS version. The corrected version, which is probably the lower end of the scale, says temperatures falling. Really? I don't know about that. Anyway, in October at 1.25 to 1.3 degrees, and then going up to only 1.5 degrees, which is the bottom threshold for a strong El Nino. Between this, the bottom end, 1.5, and this, the upper end, the top at 1.9, I'd say we're going to end up somewhere around a 1.7, maybe a 1.8 degrees above normal, solidly in the strong El Nino category. But at this point, no hope for a super El Nino. And clearly looking at 97, the sea surface temperature data, we're not there. That said, we're stronger than 2015, and 2015 ended up being a super El Nino. So who knows? Are the models completely out of it and don't have a clue as to what's coming? I'm not going to go that far, but we'll see. All right, so let's put a bow on all this stuff. What's going on? Our current status. More solid cloud pattern, that negative outgoing long radiation, is building near the dateline and has been since 624, but clearly it's more evident now than it's been. Than it's been in the past month or so. Equatorial currents suggest the Walker circulation stronger effects at the surface. Yep, Walker circulation building, at least according to the currents. The North Pacific jet stream, well, it doesn't look great. I still think there's a 6-week delay in what's going on, so we'll just leave that, sort of put a pin in it for right now. The SOI is building and building negative. That's good. West wind anomalies holding over the Kelvin wave generation area, and they have been since 7:15. More good news. New Kelvin wave development continues, yes, or we should say the 6th Kelvin wave is making its way across the Pacific and looking good and backfilling into the existing 5 before that. Great, more fuel for El Nino. And so models all suggest more of the same moving forward, but the inactive MJO, we got about 10 days of that. So next week's video, you can already hear the headline right now. Well, we'll see. I'm not going to wring my hands like that. And we're just going to say, I think 10 days we can survive that and move on. We've survived a lot worse already this summer. So, unknowns. Is the Walker circulation building towards El Nino? I don't think that's an unknown. I'd say it's happening. 85% confidence, 15% that it isn't. Will west wind anomaly pattern continue over the Kelvin wave generation area? I'm upping that too. 80% yes, 20% no. Yeah, I've noted the 10-day stall. Are more Kelvin waves in flight or expected? Sure, one more. Is the ocean atmosphere coupled? We are getting there. I'd say we're 70% coupled, 30% uncoupled. Give it about a month, and I think this number is going to go up considerably. Will the warm pool in the east discharge before coupling occurs? That was kind of a concern a couple of weeks ago. Say only a 10% chance of that. 90% chance that it will stay in place and not discharge, especially with that new Kelvin wave moving in. Is model guidance believable? I'm going to up that. It was 65%. Now I'm saying 75% believable, 25% not. But if you have a different opinion, let me know. Write it up in the comments. All right, so quick summary. Are there waves? Yes, there are. Southern hemi swell hitting. Actually pretty solid today. Fun, rideable, and clean. And more coming for days with a second pulse maybe starting Tuesday. There'll be southern hemi swell the whole way through the rest of the work week coming up. And Hawaii gets in on some of the action too. A little bit of surf for them as well. And potentially another bout of southern hemi swell developing while we wait for the North Pacific to wake up. we think it'll still be another 3 or 4 weeks for that. No early season recurving tropical systems from off Japan are expected. We were hoping for that under super El Nino conditions, but we're just not seeing it now, so we'll have to live with that. But if the southern hemi keeps working, we'll take that until the North Pacific comes online. Beyond that, El Nino, things are looking good. El Nino, another Kelvin wave in flight. The warm surface pool continues to build off of Ecuador. The Walker circulation looks like it's finally starting to get established. That means the ocean and the atmosphere are starting to get coupled. And at this point, given the immense eastward displacement of this El Nino, it seems like it will not be denied. It has good fundamentals, good legs, its foundation is solid, and it isn't going anywhere anytime soon. I think we just have to be patient and wait for the paint to dry, as one of our readers suggested. It's been, it's like watching haircuts or watching the grass grow or whatever it is. Maybe not exciting, but you know what? It is coming, and it will not be denied. And so with that, that's our forecast for this week. If you enjoyed the video, give us a thumbs up. If you have questions or concerns, write them up in the comment section. We'll be happy to reply, and we tried to do that pretty quickly. If you have any bets on what you think the Nino 3.4 surface temperatures are going to get to, write them up, and we'd like to hear your opinion on that as well. Other than that, please subscribe. You can do that by hitting the Stormsurf logo down in the lower right-hand side of your screen, and you'll get automatic notifications when the videos are posted. If you'd like to make a small donation, use the super thanks button down below. And with that, that concludes our video for tonight. But we're going to do it again next week, same time, same channel. Thanks for watching.